Okay, Bismillahirrahmanirrahim. We start our lecture today for the next chapter. It is chapter number uh, 11. It is named as a mathematical induction. It, for the mathematical induction is to prove the most basic case. First is to prove the most basic case. Secondly, we want to assume the statement that hold some k for all the number less than or equal to k. And then number three, it is based on the induction step to prove the statement hold for the next step based on the induction hypothesis. Okay, this one is based on the statement. Okay, and then natural number, and then it based on the iteration. Okay, a proof by induction consists of two cases. The first is the base cases or the basic that prove the statement for the n is equal to 0 without assuming any knowledge or other cases. And then the second case is to prove the induction step based on the iteration step that proves that if the statement hold of any given cases by the n equal to k, then it must also hold the next case n equal to k plus 1. Okay, they have two cases here. Okay. Okay, this one is just for the glimpse of the topic. Okay, first one is to prove the statement. Okay, prove the statement. Okay, kn is equal to 0. Okay, and then the second is to prove uh, to hold that n equal to k, and then n equal to k plus 1. This one is the next cases. Okay. Actually, what is the induction? Induction is a method of proof to prove the most basic cases. Secondly, it does not generate answer. It only can prove. Okay. And then it consists of three parts or three elements. First one is the basic or base case. So it is true for one element. Okay, and equivalent to one. And then inductive hypothesis assume that it is true for any given element must be clearly labeled. Okay, and then that if it is true for the next highest element, it must have the inductive step for the iteration. For example, here is a domino effects. Okay. For example, for the induction, they have a three step. First one, show that n is less than 2 power of n for all the positive integers of n. Okay, let Pn be the proposition of n less than 2n. And then the most basic case, show that P1 is true. So we replace P1 by the 1, and then we can find that 2 power of 1 is equal to 1, and 2 power of 1 is equal to 2 lah. Okay, is equal to 2. Okay, it is true lah. Okay, and then inductive step, show if Pn is true, then Pn plus 1 is true lah. Okay, that we assume that n less than 2n is true. So we need to depict or to show that Pn plus 1 is true. For example, n plus 1 less than 2n plus 1. Remember, for the uh, first cases, we could prove the statement. Okay, we start from n less than 2n. therefore, we have n plus 1 less than 2n plus 1 less than or equal to 2n plus 2n is equal to 2n plus 1. If n less than 2 power of n, then n plus 1 must be also less than 2n plus 1. Okay, we can conclude that Pn must be true for any given positive integers. So n less than 2n is true for any positive integer and end of proof. Okay. Okay, this one is the example. Induction example show that the sum of the first n odd integer is n power of 2. Okay, for the sum is the we can have this one. This one is the symbol of sum. Okay, and then if n is 5, we can find 1 plus 3 plus 5 plus 7 plus 9 is equivalent to 25 is equivalent to 5 power of 2 lah. So formally we can show or demonstrate by using the first that we I have explained to you is based on the base case. First one is based on the base case to show that P1 is true. So we can have the sum of, okay, we have sum of I equal to 1. Okay, this one maximum is 1, and then we have 2i minus 1. Okay, and then here we can show is true because 1 is equivalent to 1. Okay, and then the sum of the first and integers is n power of 2. Okay, first, okay, we can have the terms, the summation terms. And then to decide the formula, we list out A1, A2, A3 until AN. And then with the n is the odd integer. Okay, we can have A1, we replace equivalent to 1. A2, we replace 2 power of 2 multiplied by 2 minus 1 is 3. 2 power of 4 minus 1 is 7, and until so on. Until we got the formula 2n minus 1. So the formula is correct. Is equivalent to n power of 2. Okay. And then for the base case, P1 is true. So we replace the I equivalent to 1. And then we can show that 1 is equivalent to 1. Okay, this one is true. The value is true. Okay, so far do you have any question? Boleh ke? Okay. Okay, and then second step is to inductive hypothesis. Assume the true for k. Thus, we assume pk is true, or that we have sum of k 2i minus 1 is equivalent to k power of 2. K we replace n we replace by k. Remember, for the first is to prove that n equivalent to k, and then later on n the next case is k plus 1. Okay, and then here we replace k equal n equal to k. Okay, and then we replace k. Okay, and then we can have k 2i minus 1 is equivalent to k power of 2. We replace the n here. Also, we don't know yet if it is true or not lah. So we can have the inductive step, iterative step to show for the k plus 1. So we replace the total sum of k plus 1, I equivalent to 1, 2i minus 1 is equivalent to k plus 1 power of 2 because we replace k plus 1 here, k plus 1. Boleh ke? Boleh ke? semua. Yang ni kita ganti je. We replace the n kita replace je n. So by replacing the k, we have 5 5, we have ai plus a1 a2 until a5 because the maximum is 5. And then for the formula, we replace k plus 1 is total sum of I equivalent to 1. And then this one is the term formula is equivalent to k 2i minus 1 plus a k plus 1 lah. We replace okay, we replace 2i minus 1 is equivalent to 2i minus 1 plus ak plus 1 lah. Okay, this one is the AK. We replace this one is later we see. This one is the list is for the K. Okay, and then AK plus one is we replace the last element, and then we got 2K plus one. Here, total up of I K plus one to I minus one is equivalent to K to I minus 1 plus here ak plus 1, and then we got ak plus 1 is equivalent to 2k plus 1. Okay. So this one is the a1 a2 a3 we list out again. This one iteration for the total sum of 6 ai is equivalent to 5 ai plus a6. Okay, this one k plus 1 ai is equivalent to total sum of k ai plus ak plus 1. Okay, and then we recall the hypothesis. We have the ak is equivalent to n. We replace the n, and then ak plus 1 we replace n minus 1 lah. So here the inductive step. Later I show you another example. I have at least 10 example. Don't worry about that. You see and try to understand first. Okay, this one is inductive step. Okay, this one is ak plus 1 to I minus 1 lah. Okay, and then we want to prove this one is we replacing k power of 2. Okay, k power of 2. This one is k plus 1 is equivalent to k plus 1 power of 2 and power of 2. Okay, so we replaced, we got the 2k plus 1 minus 1 plus k power 2 is equivalent to k power 2 plus 2k plus 1. So this one is true because we got same. Okay. Okay. In other words, we can show that the P1 is equal and for all k, pk is implies pk plus 1 is implies to for all n pn. Okay, the idea behind the inductive proof, this one is just to recap back again. First, we want to show the base case. Secondly, show the inductive hypothesis. And then manipulate the inductive steps so that you can substitute the part of inductive hypothesis. And then show the inductive step. Okay, we have an example, another example I give to you so that you can relate and understand. Okay, first we have A. Okay, we have A. 4 plus 9 Kita buat sama-sama Plus 14 plus 19 plus dot plus 5n minus 1 is equivalent to n 3 plus 5n. Okay, what is the first step? Kita nak buat apa ni? Ami kita nak buat apa? First is we show the basic step lah. Alvin boleh ikut ke Alvin? Can you follow me? N equivalent to 1 lah. So n equivalent to 1, we have 5n minus 1, we got 5n minus 1 is equivalent to 5, 1 minus 1 is 4 lah. Okay, and then here we got 4. Okay, so equivalent to we replace here pula, here. Okay, 1 divided by 2 is 3 plus 5, 1 lah. Okay, so we got 5 is equivalent to 1, 8. Okay, so we got here 4 is equivalent to 4. Boleh ikut ke? This one is true. Boleh ke? Okay, kalau ada soalan tanya this one is a basic step basic step which means that you can you need to prove Second is to show the inductive hypothesis. Inductive hypothesis has two lah. First, you need to prove that k is equivalent to 1 and then k is equivalent to k plus 1 lah. Okay, so second is induction step. And equivalent to k. Show true for n equivalent to k plus 1. Okay, this one is induction step. So we assume four plus 9 plus 40 plus 19 plus plus 5 and minus 1 is equivalent to n power 3 plus 5n. Okay. So when we assume, we replace 4 plus 9 plus 14 plus 19 plus dot 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 plus 5k minus 1 is equivalent to k divided by 2 3 plus 5k. Boleh? Boleh ikut Okay. We replace this one. Boleh ke? Okay. Now we want to show. Okay, and then we recall back the inductive hypothesis to substitute, so you can manipulate the inductive step. Okay, the next one is to show, sorry, 4 plus 9 plus 14 plus 19 plus dot 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 plus 5k minus 1 plus 5k plus 1 minus 1 is equivalent to k plus 1 divided by 2, 3 plus 5 k plus 1. Okay, boleh Okay. So, okay, here until here. Okay, we got k divided by 2 is 3 plus 5k plus 5k plus 1 minus 1 is equivalent to k plus 1 divided by 2, 3 plus 5k plus 1. Okay, boleh ke? Okay, here is here. So we calculate k, sorry, divided by 2, 3 plus 5k plus 5k plus 4 is equivalent to k plus 1 divided by 2, 3 plus 5k plus 5. Kita buka kurungan dia. Okay, we open up the bracket plus 5. Okay, and then okay, we got okay, 3k divided by 2 plus 5k power of 2 divided by 2 plus 5k plus 4 is equivalent to k plus 1 divided by 2, 8 plus 5k lah. So here we got 13k k plus 1, okay, here k divided by 2 plus 5k plus 4 equal to 8k plus 1 5k. So finally we got 13k divided by 2 plus 5k power of 2 divided by 4 then divided by 2 plus 4 is equivalent to 13k divided by 2 plus 5k power of 2 plus 4. Okay, this one is same Boleh ke? Yang ni kena sama dengan yang ni eh? 5k, 3k campur 5k power 2 campur 5k campur 4, okey. Okay, boleh ke? Okay, another example to show the sum of the first n positive even integer n power 2 plus n. We rephrase whereby the for all n pn where the pn is the sum of 2I is equal is same with the n power of 2 plus n. First, they contain three parts: base case, inductive hypothesis, and then inductive step. Hypothesis yang tadi tu we have k equivalent to 1. We have k is equivalent to n. We have n equivalent to k, n equivalent to k, and then n equivalent to k plus 1. Okay, to show the inductive step. So the case P1 assume okay n is equal to equivalent to 2. Okay, and then for the inductive hypothesis, we assume by replacing the k, n by replacing k power 2 plus k, and then we have a k to show that we need a k n equivalent to k plus 1 here. Then p k plus 1 is equivalent to k plus 1 total out to 2i equivalent k plus 1 power 2 plus k plus 1 and then to the inductive step. To recall our inductive, we have n power 2 plus k, this one. Okay, and then we recall here. Okay, and then k plus 1, k plus 1, and then we have 2k plus 1 plus the k equivalent to k plus 1 power 2 plus k plus 1. Okay, and then we have 2k plus 1. We have I. We replace by I. K. 2i is k power of 2 plus k. K power of 2 plus k. Equivalent to k plus 1 power 2 plus k plus 1. So we got the same output. Okay, to recall our hypothesis, this one is true. Okay, another okay, not for the proof of induction. We manipulate the k plus 1 case to make the part of the look like the case of k. So we replace the part of the other side of k case. Okay, here we can replace. We replace this one by k power of 2 plus k lah. Yang ni kita bawa dia ke sini. Okay, we replace. Okay, because of the n power 2 plus n lah. Okay, based on the this one. So k plus 1. Okay, k plus 1. We want to replace by n power of 2. Okay, n power of 2 plus n lah. Okay, k power of 2 plus n. Yeah. Okay, so we replace this one. We replace by using the statement. So 2k plus 1, so we can total up is same lah. Okay, another example. Rosen to question 7 show the total sum of n, I equivalent to 1, I power of 2 is equivalent to n plus 1 to n plus 1 divided by 6. Okay, based on the n equivalent to 1, we can assume this one is true lah, because the 1 is equivalent to 1 lah, 2 equivalent to 2 and so on lah. And then for the inductive hypothesis, assume that pk is true. Second step, this one is second step. Okay, is equivalent to k k plus 1 to k plus 1 here. Okay, and then to show the inductive step, induction step, we plus k plus 1, k plus 1. So k we replace by k plus 1, k plus 1, and then k plus 1 plus 1 and 2 k plus 1 plus 1. So here here we replace here. Okay, so k plus 1 power of 2 is plus total sum of k is equivalent to 1, I power of 2 is equivalent to k here, plus 1 k plus 2, and then 2k plus 3 divided by 6, and then this one is equivalent to k plus 1 to k plus 1. So finally we got the same. Okay, okay, another the third induction again. What is if the inductive hypothesis was wrong? Okay, first base case is wrong because the one is not equivalent to the other side. Left and right is not the same. Second is inductive hypothesis, but let's continue anyway. Assume the PK is true. We replace K plus 1, N equivalent to K, and then N equivalent to K plus 1. So, N is K plus 1. Okay, to show that PK is true, okay, this one we replace this one to this. And finally, we got a 14k plus 6. This one 16k plus 8 is false, is wrong. Okay. And then fourth induction example. Okay, show that n exclamation mark is not is less than n power of n for all n greater than 1. And then for the base case, n is equivalent to 2. Okay, because the n is greater than 1. Okay, so that we can show that 2 is less than 4 lah. For the inductive hypothesis assume is we replace n equivalent to k. So we replace this one k. Okay. For the inductive step, we need to n equivalent to k plus 1. Yeah. Okay. Okay, this one is exercise principle 1 to 3. Okay, show inductive hypothesis, and lastly is to show if it is true for the highest element. Okay, for the base case n equivalent to 1, we finally find out the same is true. Inductive hypothesis assume n equivalent to k. Okay, this one is the next step. Okay, we assume k plus 1 divided by 2, and then for the inductive step, we recall, okay, k we replace it by k plus 1. K plus 2 divided by 2 is we can okay, for the n plus k plus 1 divided by 2, and finally we got the same. Okay, for the total sum of k plus 1 divided by 2 here we replace. Question 2 also same. Okay, finally we got the same. Okay, another example is to prove 1 plus 2 plus 3 plus n is equivalent to n plus 1 divided by 2 lah. And the basic is n is equivalent to 1, and then we can find this one is same lah. 1 is equivalent to 1. And secondly, for the inductive hypothesis, n equivalent to k. And then this one for the total I equivalent to 1 is k lah. K plus 1 divided by 2. Okay, here is k plus 1 divided by 2 plus k plus 1 here, and equivalent to k plus 1 is equivalent to k plus 1, k plus 1 plus 1 plus 1 divided by 2. And finally, we got the same k power of 2 plus k plus 2k plus 2 lah. Okay, we got the same answer, and then it is true. Another example, this one is for the basic. For the basic, for this 1 plus 3 plus 5 plus 2n minus 1. If we replace 2n, the terms we can have here 1 plus 3 plus 5 plus 7 and so on. Is equivalent to n power of 2. For the basic, we can get the true answer. For the assume n equivalent to k. Okay, and then we assume that uh, 2n to k minus 1, okay, it's equivalent to n power of 2 lah, k power of 2. And then to show, to recall, is n k plus 1 lah. So this one is k power of 2 plus 2k plus 2 minus 1 lah. Here. Okay. 2k minus 1 here lah, is equivalent to k plus 1 power of 2 lah. So finally we got k power of 2 plus 2k plus 1 is equivalent to k power of 2 plus k plus 1. Same lah. This one is 2k lah. Okay, and then this one is another example. Okay, 1 plus 2 plus dot 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 plus n is equivalent to n plus 1 divided by 2. Basic is n equivalent to 1. Okay, is basically it's natural number. Finally, we got the same here. Okay, okay, to assume n is equivalent to k, and then to show n is equivalent to k plus 1, we replace. To show, kita kena replace. We need to replace. And then here we can find the k plus 1 divided by 2 plus k plus 1 is equivalent to k plus 1, k plus 2 divided by 2 because of here, k plus 1. So we got k plus 1, k plus 2. Okay, finally we got k power of 2 plus 3k plus 2 is equivalent to k power of 2 plus 3k plus 2. Okay, so far do you have any question? Ada soalan ke? Saiful, okay Saiful? Hmm, saya bagi contoh lain lah. Sebab kalau kamu tak faham, kamu tak boleh buat Okay, we have here the question 1. Boleh tengok saya punya contoh ni. Walaupun tulisan tak cantik, harap kamu tengok YouTube saya. YouTube saya kamu tengok tak? Walaupun tulisan tak cantik, suara tak sedap, tengok je lah Jangan komen banyak sangat. N plus 1 divide by 2. Okay, kita ada berapa step tadi? 3 kan? Show true for n equivalent to 1. Basic lah. We replace when we replace this one, kita kena replace dekat sini. Faham ke? Okay, so we have 3, 1 is equivalent to 3, 1, 1 plus 1 divided by 2. This one 3 is equivalent to 3 multiplied by 2 divided by 2 lah. So we got 3 is equivalent to 3. So the answer is, jawapannya apa? True lah. Boleh ke anak-anak? Kemudian kita assume true for n equivalent to k lah. So the next one is we assume tadi kita nak buat apa? Assume biasa kita buat apa? Assume true Assume true for n equivalent to k. Ni assume true saja So kita akan dapat so we can get k 3 plus 6 plus 9 plus 12 plus plus 3k is equivalent to 3k k plus 1 divided by 2. Boleh ke? Kenapa jadi k ni? Siapa boleh tolong saya? Sebab we assume true for n equivalent to k. Yeah. So number 3 kita nak buat apa? Kita nak show the iteration So we show true for n, show true n equivalent to k plus 1. Boleh ke? Amir boleh? Amir Dai boleh ke? Okay, so yang kat sini kita akan dapati 3 plus 6 plus 9 plus 12 plus plus 3k plus 3k plus 1. Okay, is equivalent to 3k plus 1 k plus 1 plus 1 divided by 2. Yang ni Okey. Ada soalan ke setakat ni? Ada soalan ke? Okay, we got 3K, K plus 1 plus 2 eh. So yang ni kita tulis yang ni yang ni semua sampai sini adalah kita wakilkan dia dengan yang ni tadi eh. Represented by this one. So dot kita buat kat sini eh. Nanti kita ada 3K K plus 1 divided by 2. Okay, lepas tu nak buat apa? Okay, kita ambil yang ni pula plus 3K plus 1 okay, is equivalent to okay, 3K plus 1 K plus 2 lah divided by 2. So kita ada 3K K plus 1 plus 6K plus 1 divided by 2 is equivalent to 3K plus 1 K plus 2 divided by 2 lah. So we got 3K plus 1 K plus 2 lah. Okay. Okay, we simplify this one. Okay, divide by 2 is equivalent to 3K plus 1 K plus 2 divide by 2. Boleh eh? Sama kan? By the process of 1, 2, 3, 4, we can conclude that 3 plus 6 plus 9 plus 12 plus 3 n is equivalent to 3n n plus 1 divided by 2 is true. Okay, this one is true because we got same here. Boleh ke? Okay, this one is just for the example. I give you a lot of example. You need to replace. First, you need to show the true for n equivalent to 1, and then assume for true for n equivalent to k. And then to prove, you need to show the n equivalent to k plus 1. And then you need to restate back by conclusion. By the process of here, you can find the answer is true or false, true or wrong. Okay.